All right, I think we'll go ahead and get started. I see people are still coming in to the webinar. So as they get settled, I'll just do a quick introduction here, and then we'll turn it over to David Horster, who will be our presenter for the day, and he'll take it from there. David, can you advance the slide one, please?
Sure.
So thank you, everyone, for taking the time to join us for our May Oxygen Blast presentation. We're thankful to have David Horster join us, and David will be introducing himself a bit here after I'm complete here with my intro, and then we'll get started. So we do have another Oxygen Blast scheduled for May, focused around, or excuse me, for June, focused around SQL Server. So you can check that out via our website. Before David does jump in, I want to do a quick intro of Intertek for those of you that are on the call and not familiar with us. Our firm has been around since 1991 and has grown to be the largest software and IT training and consulting firm in the state of Minnesota. And in the past 10 years, we've expanded quite a bit nationally and globally. We've won over 40 awards for growth and top workplace best practices. And a lot of that's due because we put a lot of emphasis on customer satisfaction. We have sort of a unique model as far as we have a training operation and we have a consulting practice. And we like to have our consultants in the training operation and our trainers in the consulting practice, which helps us bring the real world into our classrooms and also teaching a part of our consulting practices. We've maintained some pretty stringent hiring practices over the year that have helped us build a very experienced staff that helps empower Fortune 500 companies with software and IT innovation, as well as mentor, teach, and train their software and IT professionals. So been a good model for our growth, and more importantly, a good model for our customers' growth. I will be on Twitter with hashtag OxygenBlast. If any of you folks are on Twitter, I'll be there, and if there's any discussion happening there, we can certainly do that. Otherwise, at this point, I'll make note of the fact if you have questions, please use the Q&A box. If we don't get to all of your questions, I'll follow up afterwards with answers to your questions, but I will try to jump in here and there if people have questions. And this is being recorded, so after the presentation, we will get that ready and send out an audio and an audio recording as well. So with that, I'll turn it over to David, and he can get going.
Thanks, Pat. All right, let me advance my slide here. I'll turn it back. So thanks, everyone, for joining us today, or joining me today, talking about creating modern web applications with ASP.NET Web API and SignalR. My name is David Horster. I'm actually out of Pittsburgh, Pennsylvania. I'm actually a 5-time .NET MVP. I think my bio had 4-time. I just got renewed last month. I'm a senior solutions architect at Confluence in Pittsburgh. We build software products for the financial management industry. I'm one of the co-organizers of an event called Pittsburgh Tech Fest. If you're familiar with co-camps, Tech Fest is, we like to think we take it up a notch. So we don't specialize in a specific technology. We kind of, it's a festival of all different types of technologies. And actually, our next one's coming up next month. So if you're in the Pittsburgh area around June 13th, stop on by. I just organized or began a reactive developers group online through Meetup. So we haven't had our first meeting yet, but we're planning on that. So I'm a big fan of like the Reactive Manifesto, actor development type of things like that. And I used to be the president of the .NET Users Group here in Pittsburgh. If you want to follow me on Twitter, it's my Twitter handle. I blog every now and then here, and if you ever have questions, you can always reach out to me via email, and I will do my best to get back to you as soon as I can. So what I'd like to talk about today around modern web application development with Web API and SignalR is just quickly just talk about sort of some recent app trends and kind of going back over the last so many years of kind of where we've been, and just quickly talking about what is this one ASP.NET vision that Microsoft has they've been talking about for a year or so, and just digging into Web API a little bit. We only have an hour, actually less than an hour, so we can't dive too deep. unfortunately. But at least just looking at web APIs in general, and I have a couple applications that we'll demo. And I just looked at how web API kind of plays a role in these types of different types of client applications. And if I'm also a fan of OData and the OData enablement in web API. I think it's a pretty powerful pairing of data and access. It's pretty nice there. And then, of course, the last half where we'll start focusing on SignalR and incorporating SignalR into your applications. What SignalR is all about and how you can start taking advantage of that. So I have two little demos around SignalR. One is sort of the canonical chat application, and that one's real simple, and I should say it's ridiculously simple. And the second one is more of a broadcast type of approach of using SignalR. And if you've ever seen me present before, either online or at regional events, I love baseball data. So I figured we'll use SignalR to simulate sort of like a real-time baseball scoreboard. And showing, if you've ever seen like ESPN or those kind of sites where they always update every single game, every out, that's what we'll try to simulate and see how that goes. I would like to try to focus a little bit on demos and code in this session. I don't want to bore everybody with slides throughout the entire time, but we do probably need to start with some slides to kind of kick things off. So with that, we'll get started. So I don't want to spend too much time on these slides here, but I think it is interesting to at least take a look at how we've sort of evolved our application development trends over the past couple of years. So this kind of goes back to when I started. This shows how old I am. Building web applications, although 2000 doesn't seem very long ago, but apparently it is. And I did get started in classic ASP in terms of web application development. And just the way ASP was, it's really a mix of markup and presentation logic. We didn't really use a lot of JavaScript. It was a single page for every single URL. And we used COM quite a lot, obviously. But everything was really on the server side. There's very little that was being done on the client side, except for just a little bit of JavaScript for validation. And then over the years, ASP.NET came into being. So like around 2003, ASP.NET came out, and it was sort of this revolutionary type of thing of separating, your markup and your post-back code behind logic. But you still had a lot of action happening on the server side. So a lot of server-side controls. There still was this tight coupling between presentation logic and your markup. You still had this single page per URL. You had less COM, but since .NET was still fairly new, there's still a lot of COM floating around out there. And then, you advance a few more years, you start getting ASP.NET, and AJAX suddenly becomes the hot topic. Gmail, Google Maps, start coming out. Everybody's like, oh, this is amazing stuff. And you start seeing a little bit more separation between that presentation and markup. You still had server-side controls, though. But then you ended up with this thing called the AJAX Control Toolkit and the update panel, which at the time, everyone thought, this is amazing. I can start updating sections of my page without refreshing the entire page. So I didn't have that whole flash happening, which was wonderful. And JavaScript became something more than just validation, mainly because of the advent of jQuery. And people actually found that JavaScript was actually interesting to program in. We still had single pages per URL, and now we started asking ourselves, well, what's that COM stuff again? I forget. But then you start going into the last 5 years. So MVC starts coming into play. Web form starts to fade away. Less focus on the AJAX Control Toolkit and more focus now on JavaScript frameworks. And so now we start focusing a little bit more on the client side. And MVC was kind of like a replacement for web forms. It provided a nice, much more clean separation between your presentation and your server-side logic. But the thing was is that your view results that came out of MVC were still kind of tied to pages, although you still had these things called JSON results. So you could actually get back more than just a page. You could actually get data back. But then that led to Web API, which is what we're going to start talking about today. And really, we start cleanly, or not cleanly, but more cleanly separating our roles between client and server, moving presentation logic much more towards the client, having the server really do what the servers are really good at, and that is processing data. And that's kind of where we've been for the last couple of years. JavaScript and CSS frameworks are now becoming much more into prominence. You hear people say, "Well, jQuery is dead. It's it's no longer relevant." But I differ on that. But there are lots of JavaScript frameworks out there, and so we'll look at an Angular application tied into Web API here in a little bit, and that's a really nice marriage between client-side and server-side type of technologies. And really, it all comes down to services. 10 years back, we talked about service-oriented architecture, SOA, and everybody had their own definition of what that was. But I don't think anybody really knew what that was. But service-based development is really becoming much more of a real thing these days. And Web API really lends itself to start allowing you to build true services that applications can connect to. You can build those services pretty easily and really just allow any type of application to start connecting to them. And JSON becomes the lingua franca of all your RESTful services. And really this becomes the common language. How do I communicate between different services? And JSON really becomes that format that everything speaks with. 5-7 years ago it was XML. That was too fat. JSON is much more streamlined, yet still providing much of the same richness of information that XML did or does. And then, of course, today, that list of technologies on the ASP.NET stack just seems to keep growing, which is wonderful because now there's so many more choices out there. You're not just stuck doing just web forms development. You can now start saying, well, I can mix and match MVC and Web API. Maybe I'll throw a little bit of OData in there, and then use SignalR to kind of update things here and there. And that's great. That's a great like cafeteria style approach of picking and choosing what your application really is going to be and what types of tools that your application is going to use. And so being able to pick or mix and match these different technologies really goes a long way. So obviously the single page application is the hot style these days between Angular or Ember and all the other frameworks out there. They're all primarily JavaScript driven. So JavaScript really has become a powerhouse in terms of a language. We pretty much have to start learning it. Can't avoid it any longer. But really, it's becoming more than just this quirky language. And with ES6 coming out soon, it really is going to become a much tighter language, a much more consistent language too. So I think we're sort of probably in the early day of a renaissance around JavaScript. And really, it is a service-driven type of world now. So this is really where Web API comes into play and it really shines. So again, what we're seeing now is that a single page loads, but then that single page then starts bringing in different chunks of data. So kind of like what the update panel did way back when, except it's much more efficient. We're just purely targeting just different parts of our page or our application to update. We're not loading entire sets of data all at once. It's very targeted, very specific, and really focusing in on what it is that we really need to do. So when we start talking about one ASP.NET and what that really means, if we think about and this is somewhat I don't want to say traditional because it's not that old, but typical is probably a better word for it. So you might see a lot of .NET web applications these days kind of look sort of like this. So some vague language there. But if I have my general web application, the structure of my web application could be an MVC application. And that MVC application, there could only be just a handful of views, maybe 2, 3. Login page, main landing page, and maybe some custom help and some other little pages here and there. But for the most part, just probably a handful of views, not much else. That MVC structure then essentially houses your client framework. So maybe it's an Angular or Ember type of application that's contained within that MVC structure. And really, the interaction between your web application and the cloud or your services is really going through that client framework up to the cloud to access your data via services, and that's really through Web API. So we've already, so we typically see now this mix of MVC and Web API together to sort of build sort of the best of both worlds type of application, providing sort of a server-side creation of the structure of my application, but then creating individual services for very specific things that my application needs. And it's also possible, too, that these services could also do some communication with a hub. That could be through SignalR. And that SignalR hub could be communicating back down to a client's, the JavaScript framework that then updates various parts of your application. This arrow actually should be two-directional. So the beautiful thing about SignalR is that it really is, it's almost like the old school RPC, remote procedure call type of framework, in that the JavaScript could call into the hub could call back down to the framework. So you can sort of have this two-way communication happening. And that's really what's happening here, is that this one API on vision is that part of my application is MVC, part of my application is Web API, part of my application is SignalR, and maybe I have something else thrown in here, some OData or whatever that might be. But it's no longer, my application is no longer an MVC application. It's an ASP.NET application that has aspects of MVC and Web API and SignalR and on and on. And that's the nice thing about it. It's no longer just targeted at a specific type of application. I mean, I know in the past, I think I had a web forms application several years back that we were maintaining, and I wanted to add MVC into that web forms application. And it was very hard to do because it was, you know, that web forms application was pretty much hardwired as a web forms application. Bringing MVC into that application, and granted this was probably like a 2010 or maybe even a 2008 project, but bringing MVC into that required a lot of heavy lifting in order to enable everything and get the routing working and all that. Today, though, it's simple. It's basically almost checkboxes when I want to start creating applications. So it makes our lives as developers a lot easier, being able just to pick and choose which pieces we want to add into our application. So as we said, you know, creating that MVC structure, or creating the structure of your application, sometimes MVC is a nice choice for that because it is still server-side. It kind of lays down for the framework that your application is going to use. And once that framework's laid down, that's pretty much it. Everything else then is sort of client-driven in terms of the templates that are loaded, and everything else is good. You know, actually, I see a couple comments on the chat box. Can everybody hear me okay? Can somebody just type in saying they can hear me? Okay. Sorry about that. I saw a couple comments come through. So, oh, there was a question also about what ES6 is. That's the next version of JavaScript. Sorry. So creating that structure is, MVC provides a nice little framework for doing that because it really is server-side generated. You can kind of set everything up in terms of who the user is and what maybe authorizations they have, and then kind of stream that back down to the client, and then let your client framework take over from that point, and maybe just make API calls going forward. The service layer then is really what the client-side framework is going to start interacting with. So that's really that line from the JavaScript framework up to the cloud, accessing your API or your services via Web API. And Web API really does provide a nice little facade into your data. You can tailor your API services based on the type of data you want to provide back. It is much more RESTful than, I would say, an MVC because it's really driven by the HTTP verb that you're trying to access. So whether it's a get, a post, a put, or a delete, that's really driving sort of your action methods within your API. Whereas before with MVC, it was much more, you would have lots of like, get person type of methods or get person by address or whatever that might be. Web API is much more driven by what verb are you using, what type of entity are you getting. Sort of that combination of the two tends to drive that service interaction. The other nice thing about Web API is that's really not bound to a web client. Your communication is really all through HTTP. So if the client that you're using can use HTTP, basically you can communicate to Web API. With MVC, MVC was much more bound to a web client, to a browser client type of thing, whereas Web API is pretty much, it's all just HTTP, which is really nice. And we'll show communicating to a web API layer, both through just a regular browser, really through JavaScript, and then also through just a console application, how you can do that. It's pretty easy, actually. And then lastly, that real-time communication layer ends up being SignalR, and it's more like a publish-subscribe type of model, although it's really a two-way pub-sub type of thing. So it's a little bit more strange than just a plain old pub-sub type of model, where either end of the communication channel can really be the publisher or the subscriber. So it's kind of neat. So let's just talk real quick about MVC, just in brief. So I've said that it's kind of the successor of ASP.NET Web Forms. It really is server-side generation of your initial content, and that's why it's probably good as an initial provider of your application structure. Anything other than that tends to take you back towards the web forms type of approach of application development, where every link you go to becomes sort of a brand new page that you're going after, which could be fine. I mean, based on the application that you're building, that might be what you're after, or maybe it's some sort of internal admin type of application, and you really don't need that really rich experience. MVC can be really easy just to fire up and get it running. You don't have to worry about doing things the Angular way or how Ember might work. So MVC is still a viable option. Still is an actively developed library at Microsoft too. So I don't think it's going anywhere anytime soon. But just remember that it's much more tied to the web. It's really driven by results and views. It's really its whole modus of operating is really just based on I need to return some sort of view back to the user, and that generally is HTML. It can also be data, but that's kind of not exactly what MVC is for. It's really about presenting back to the user, here's an HTML form, or here's some sort of view that shows you the representation of the resource that you're going after. And so in that sense, that's why MVC is somewhat the next generation of web forms. But Web API, though, doesn't really care about pages or markup or any of that type of thing. And I think that's why I'm much more of a data person rather than a front-end engineer. So when you see some of my examples, they're not the most amazingly crafted web pages, but I'm really much more about the data. And Web API really appeals to me because I want to be able to create services that generate and provide the data to the client applications in the way that I find most efficient and best suited for their needs. And from my perspective, Web API is really that framework that does that for me. So it's really just all about presenting data. There really is no concept of a view in Web API. So I still have the concept of my back-end model. We'll talk about that in a moment. And I still have this concept of my controller, which essentially is sort of the main hub that clients go through in order to get data out. But nowhere in there is saying this is the markup, this is the page, this is HTML. To me, my language that I communicate back with Web API is JSON. And it is much more RESTful in nature. As I said before, it's really driven by the HTTP verbs, and these 4 verbs here are the primary ones that you may be working with. Gets generally would be associated to selects, if we're talking database technology or terminology. Posts are generally inserts. So I want to post some new information up. I'm basically doing an insert into my underlying repository. Puts are updates. So I'm going to, if I put information to a Web API, generally I'm associating some ID with an update, and that more or less would be an update into my backend repository. And delete is pretty much what it would say. It's a delete. And that really is essentially it. I'm not entirely sure how familiar everybody is with Web API, so I'm going through this a little bit fast only because we have a short period of time. But creating a Web API project is really simple. And the whole one ASP.NET concept makes this type of approach very easy to do. So if I were to go into Visual Studio and say I want to create a new project, and I create a new web application, I'm presented with this dialog here. And essentially I can pick and choose, and I'm in 2013, by the way. And I can pick and choose what type of template I want to work with. Generally, I tend to go with the empty template. and then select different types of references I want to work with. So generally, I'd select an MVC and Web API template, or MVC and Web API references to use with my empty template. But if I were to select an MVC or Web API template to start off with, what that template provides you is additional resources like Bootstrap, jQuery, and a handful of other JavaScript libraries to kind of just get you started. So if you're playing around or you just want to throw together a quick demo or put together just some sort of proof of concept to see if something works, I would say an MVC or Web API template's not a bad choice. I wouldn't rely on all the extras that it gives you, but at least you don't have to worry about style sheets and all that kind of stuff. It's sort of already put in place for you. But if you're building sort of a production quality, production ready type of application, I would probably lean more towards the empty template and add in the style sheets and my JavaScript frameworks and all that type of stuff the way I want it to be in terms of deploying to production. If you're going to use a gulp or grunt type of task manager to do a lot of minification, all that kind of stuff, definitely lean towards more the empty templates than the MVC or Web API. These are awesome if you're just doing demos, and I use them every now and then for my demos because then it's a lot less work for me to set things up. So when I start defining my Web API project, one of the most important things to keep in mind is your routing. So in terms of how clients get to your data, it's all through a route. And we'll take a look at that here once we get to the demos here, I think in 3 slides. The routes really direct your client to the appropriate controller and action. So if you're familiar with MVC, routing an API and Web API is basically the same. The major difference is that you really don't have action placeholders. So if you were to look at a typical route configuration for for MVC, usually you would see controller / action / ID. That's kind of the standard MVC route template. In Web API, the standard route template generally is API / controller / ID. Controller and ID are placeholders. These will get replaced by what your URL is in your browser. And these placeholders then direct the Web API framework, directs your request to that particular controller, and then based upon the verb that you're using, whether it's a get, post, put, delete, will direct you to the right action method, and then the ID might be any extra information you want to pass along. And in this route, the ID is actually optional, so this section of your route can actually be dropped off. It's not needed. And you can have multiple routes. There's no reason you couldn't have 20 routes. I've been on projects where they have so many routes that it becomes very difficult to even figure out what your routes are. So I would recommend keeping your routes to a small number. Try to keep your routing templates or your routing patterns very consistent so you don't have to create sort of these one-off routes. Because once you start managing 20, 30, 40 routes, chances are you'll miss one. So learn from mistakes. Also, the thing to keep in mind is that the route templates are also evaluated in the order in which you add them. So I could add multiple map routes here within this register method. The Web API framework, when it receives a request in, it's going to evaluate the route template based on the order in which you've added it to this routes dictionary or collection. So keep that in mind that if you have a very specific route, put that ahead, define that ahead of a much more generic, all-capturing type of route. So this type of route here is very generic, very open. It's pretty much going to hit almost any request that comes in. So you'd want to define this probably last, sort of a catch-all type of route. If you have routes that are very specific, maybe it's API / person / controller / ID, define that ahead of this particular route. So just keep that in mind. That's sort of a tricky thing with routing. Sometimes you may lose some time trying to figure out why a certain method's not being called, and it might end up due to your routing. So defining your routing through application logic like this is sort of the classic way of defining your routes. You can also define your routes through attributes, and we'll see that in 2 slides, I believe. One of the other important things when you start working with Web API is the models that you're working with, essentially your entities that are being returned back down to your client. So in this case here, an entity or your model that you're working with really is nothing more than just a plain old CLR object, a POCO. Just getters and setters for the most part, and you're just returning back that data. So, consider what you're returning back to your client is essentially just a DTO, a data transfer object. There's not really any logic in it. There's really not anything that a client wouldn't want to see anyway. I would not recommend keeping returning your entities back down to your clients. Your entities generally are much more your back-end type of classes and objects that drive your business and drive your business logic. Generally, you want to project your entities to DTOs and then return your DTOs back down to your client, because your entities might have other information that clients may not want to see, and you don't just want to return null for that kind of information, because then you start exposing too much. So it's generally good practice. Project your entities to DTOs, return those back down, let your DTOs be your models in your Web API services. And then lastly, the last main piece here is creating the Web API controller itself. And again, this is pretty simple. Your API controller essentially just derives from API controller itself. The API controller just provides some basic plumbing. And then really your action methods, unlike MVC, are really just driven off of the HTTP verb. There's several. It's much more convention-based than MVC. So if I have an action of get, that's going to be called with a get HTTP verb. So it can be called if I get something just through a URL in my web browser. I can either name that method get or get with particularly an ID for an integer, and this get just by itself might imply I'm going to get everything. So maybe I'm going to return back an enumeration of people, and the get with just the int ID being passed in, that's sort of a get one, get single. I could also name my methods get players or get player within its ID, and essentially just routing, or Web API is, I'll say, smart enough to know that get players and get essentially a route to the same method. Get and get player map to the same type of HTTP verb. So a get with an ID will match either one of these two. A get with no ID maps to one of these two. So that makes things a little bit easy when you start working just with convention-based type of an approach. Sometimes it's a little bit of black magic. You're not really sure what's happening behind the scenes or what's happening inside the Web API framework. But this makes things kind of quick and easy just to kind of get your actions out there and start working pretty quick. So in this case, in this controller here, I have a get and a put defined within my controller, and so I can either request this method through my browser URL, or a get request through Fiddler or something like that, and then I can just request this update essentially either through Fiddler or some other type of client application that can issue a put verb. So that makes things nice and clean. One other thing I wanted to mention just in terms of routing, instead of routing through sort of a general route class like we saw a couple slides back, I can actually use attribute-based routing to kind of keep my route definitions close to my controller. So there's not, it's kind of an easier way to kind of define your routes and kind of keep things a little bit cleaner. If you like, that's more of a style type of approach too. And then lastly, just with API controllers, really 4 different ways you can return information back out of your API controllers. Either you return void, obviously nothing is coming back. An HTTP response message essentially is an encapsulation of the model that you're returning back, that POCO, and perhaps other metadata like an HTTP status code. An HTTP action result is sort of a specialized HTTP response message. And then lastly, I can just return either a single POCO object or an enumeration of those POCO objects. So let's take a look at some demos here, and let's take a look at a simple approach here to single page application. So I have this single page application here. Let's make sure it's still running. And so I have a baseball database here. So this is actually running, this is an Angular application with a web API backend. I want to search on a couple different players. So let's say I want to search on Barry Bonds and Hank Aaron. And so I can actually get results back. So notice that really my page isn't flickering. There's really not a whole lot else going on in terms of page refreshes. If I look at I can bring this over here real quick. If I look at my network, and if I do that search again, essentially I'm just getting a single JSON result coming back of my search results, and I'm basically just sticking it right sort of in my results section here. When I click on, say, Barry Bonds, I want to take a look at Barry's stats over time. We'll get to that in one moment. And so I bring back, all his batting stats and all of his salary history, and I can take care of, look at all that. But if I look at the request that was made, notice that all I'm requesting is a card HTML, which essentially is just that, it's just a single couple divs here. So it's really just a partial piece of HTML with a lot of placeholders. I kind of have this JSON result coming back. So this is actually the result of my service call. So just a big piece of JSON. And then a series of lookup data that is being used on a drop-down list. So that's actually populating this drop-down list. So I actually downloaded this HTML template, the data that gets populated in the HTML template, and this data for this lookup list over here in 3 different service calls. And I let Angular kind of stitch it all together. So if I look at the code of what's happening here, when I make a request, I'm actually going through Angular. So if you're not familiar with Angular, and we don't have a ton of time to be able to go through all the details of Angular, but really Angular is essentially almost like an MVC type of application on my client. I actually define routes in Angular on my client through JavaScript, and I'll say, well, you know what, whenever I do a search on, and this is the URL that I was requesting, /card with a player ID, and that player ID was Barry Bonds' player ID, I want you to go fetch this HTML template from the server. And so when we looked at the Chrome DevTools, this is actually the partial HTML template that was returned back from the server. And notice it has these funny little placeholders in here too. So Angular will actually use this to this like handlebar notation to actually substitute in values. And then I want you to route the request to the card controller. And so the card controller is just a JavaScript file that I have over here. And so what's going to happen is when I make that request to /card/ whatever the player ID is, I'm actually going to make an HTTP GET request. And that GET request is going to go to API /player/ whatever the player ID happens to be. Now this is my call to web API. So this is where I'm connecting my client side to my server side. So this is actually heading on up to my player controller with the player ID being passed in. And notice that it's just a GET method. So nowhere in here am I saying /get or ever specifying what my action happens to be or what my action method name is. I'm saying I just want to go to the player controller and pass in the player ID. I'm in the player controller. Here's the player ID. And I go ahead and I query my database. Now my database happens to be an underlying MySQL database. That's not really that important. But I get my player back and I return them back. And I return back essentially a DTO. So that's what full player happens to be. Full player is really nothing more than just a bunch of data and batting, pitching, and salary information. But by doing that, I have this nice clean separation between, I keep going on the wrong controller. I have this nice clean separation between my client side logic in terms of where my data is coming from, what templates I'm using, and my server side, which is really just all about serving data. So in this case here, player controller does nothing more than just a series of handling requests. So this makes things very nice, very clean, and actually pretty easy. The thing too is that this is essentially just an HTTP client, so I can start connecting anything else up to this client. So one other thing, if we want to go back here, so I can search too. So let's do a search for Mr. Bonds. Oops. So Barry Bonds, Bobby Bonds, to do a quick search. This is actually going out to Solar, which is another open source search service. So if I look at my search controller here, actually let's go back to Dapperball, which is the primary route here for all of my stuff here. Search controller. So what's happening here is I have a search controller. When I make a selection here, I want to actually get oh, I'm sorry, wrong file. I'm actually searching on bonds, so I'm actually making a call up here to my web API. I'm returning back an HTTP response message. So not only do I responding back with my DTO, which is just my new object, and notice here I'm just projecting my results that are coming back. So this is really a series of player lookup information, and I'm just projecting it out to an enumerable of an anonymous type. So new result isn't even a typed object in my system. It's just an anonymous type. So I can just return that back. That gets serialized as JSON, and I return back an HTTP status message of OK. So I'm actually responding back with an HTTP response message that contains just an anonymous object and an OK 200 code. So now my web API, I don't even have to, I think in the old days, you'd have to start defining all your different DTO types. You can actually create your DTOs on the fly and return them as part of your HTTP response message. Sometimes that may not be the way you want to do it, because you may have some coding standard that you always have to have statically typed classes that you're returning back. But if you're doing a search result, sometimes this is really a nice way to do it. I want to just project out the shape of my data that's going to come back to my client, and just wrap it inside of an HTTP response message that just has an OK 200 code, and then let the client go from there. So I'm moving a little bit fast because we have about 15 minutes left, and I want to touch on SignalR because that's why probably most people are here. So we'll skip on the OData piece, but I want to mention one thing about OData. And I wish we had another half hour. With OData, if I do a search type of operation, so we just kind of saw in that little search screen on our demo application, I typed in just one value, and that got passed into my Solar search engine behind the scenes. I got results back, and I kind of bound them, I projected them, and I sent them back down to my client. Putting that all together on the JavaScript side could be kind of easy. Maybe I just create sort of a dynamic data object, make a jQuery AJAX call to some search URL, and then when I'm done, I just get my data back and I do something with that data. On the web API side of things, it can be kind of hard because how do I know what fields am I searching on? Do I deal with dynamically generated SQL? Do I have tons of if statements to see if certain fields are being set or not? You can start jumping through a lot of hoops. The nice thing with OData is that it sort of gives you this ability to say, you know what, on my web API, I just want to say this query or this method is queryable. I want the user essentially to be able to query on the URL and essentially filter out my results based on what they pass in terms of search criteria. Now that may sound like heresy to some folks, but essentially if I create just a search URL that has a handful of search fields inside of my filter and let OData parse that filter and essentially filter my results for me, that makes my search logic a lot easier. It really cuts down on a lot of that dynamic SQL I may have to write. It also cuts down on a lot of the cyclomatic complexity of all the different paths that my code could take based upon what somebody happens to send up. I would definitely refer you to the OData site and also on the web API or the ASP.NET web API web page and the sections on OData because they really go into a lot of detail about what's possible there. It's just a NuGet package install. and querying for OData. So to take our example with baseball players, essentially if I wanted to search for Barry Bonds' stats for the year 1995, I would just filter. I would find Barry Bonds, the player, by passing in Barry Bonds' player ID, and just my filter criteria is just year equals 1995. There's a handful of different filter criteria that you can pass in. You can string them together, and it's pretty interesting. So definitely very powerful there. Definitely worth taking a look. And I'll post this stuff up on SlideShare if you guys want to take more in-depth look in terms of OData and integrating that in with Web API. Okay, so enabling real-time updates. So incorporating sort of this concept of real-time updates with your web applications and allowing people to kind of see things happen really quickly without always having to refresh your application, which is what I call the Stack Overflow approach, which they've fixed now, but I know for years though, I would answer questions on Stack Overflow, and all I would do was just keep hitting F5 to see if somebody accepted my answer or not. They now, I think, incorporate Stack Overflow or SignalR WebSockets, so your web page updates a lot faster now. You don't have to keep polling. Or you can automatically poll. Just use JavaScript and just ping a site every 5 seconds to see if any new data is there. Is there anything new? And maybe there's other ways to do that. But SignalR is a library to assist with this, and it really takes advantage of new HTML5 WebSockets to allow those updates to happen a lot easier and a lot faster. It's a hub model, so as we saw in an earlier slide, it really allows communication between the client and the server and in both directions. So the client can talk to the server, the hub. The server can then communicate back down to the client, and it makes things pretty interesting. And it allows for this two-way communication to happen actually very simply. So sort of graphically what that looks like, really the communication is two-way, and really it's just through specific functions that you define. So on my client side, I have a function called myClientFunc, and from my hub side, I'm basically calling my client, perhaps with a specific ID or not, so I can actually target specific clients, or you can just call them all, and call the client func on the client side. So you're actually doing a remote procedure call through SignalR, and it works back up. So the client can actually call the server and call a function on the server call, and in this case, my server func. So it definitely works both ways. So let's set up a real quick chat application. So this is actually off of the SignalR site. It's sort of a real basic one, but it's pretty easy. It's really amazing how fast it was to get this up and running. So all I have is a very simple MVC page. And the MVC page just has a text box for what message I want to send, and then a button to send the message. And I'm going to define on my server a hub called Chat Hub, and it derives from Hub. Hub is a SignalR class. You can incorporate SignalR into your application through a NuGet package. So I have SignalR installed down here. So for the most part, either the SignalR core components, if you're using OWIN, in this case I'm using OWIN here, the SignalR OWIN package will pretty much get you what you need, and you're good to go there. So add that NuGet package in. Really just do a search on NuGet for SignalR and include the one that's appropriate for you. Within your OWIN startup, essentially just make a one-line call to say app.map SignalR. Essentially what that call is going to do is it's going to look through your application, look for any hubs that are defined, and essentially register them. It will find my chat hub here, because it derives from SignalR's hub class. And I've defined a single message on my chat hub that just says send. So this is kind of like the hello world of SignalR. So I'm defining this on the server, which is interesting. So I define this method called send, and I want to send to a specific, or I'm sending a name and I'm sending a message. So I'm basically sending two pieces of data through this broadcast message call. So notice that I'm saying clients, which is a built-in SignalR property. So it's really any client that happens to be connected to my hub. And I'm going to communicate to all of them. And I want to broadcast the message to all of them. And essentially, I'm passing in two pieces of data. I then have a JavaScript function over here. So I'm sorry, a JavaScript script that is referenced by my index view. And all that does, and most of the stuff just kind of sets up some jQuery selection. But the key thing is I establish a connection to my chat hub. So notice that the name of my hub, chat hub here, is the camel-cased name of my chat hub up on my server. And I'm going to basically wire up anytime I want to broadcast a message out. Essentially, I'm going to handle the broadcasted message by taking the name of the message and essentially just printing out the chat message that was sent back down to me. The nice thing too is that I can send back to that same server. So I can actually, still using the reference to my chat server, I'm going to say, well, okay, chat hub, I'm going to call the server, and I want to call the send message that is defined on my chat hub server. So basically, I'm calling this method here from my JavaScript. Essentially, what SignalR does is SignalR takes whatever's defined on my chat hub, essentially creates a JavaScript proxy for those methods defined on my hub, and essentially allows them to be called from my client-side application. So I'm basically saying, okay, my reference to my server, I want to call the send method, so this essentially is dynamic. And I'm just going to pass in the name and the value of whatever somebody happens to type in. So we go ahead and run this. And I'll take a second here. Let's close that down and get my window up. So I'll be Dave on this side of my chatter application, and this guy overloads. It's always slow when it's a demo. There we go. So let's connect to chatter. And I'll be Bob on this side. So I'll say hello. So notice what's happening here is that on this side, on this particular browser, I'm actually sending the message that Bob is saying hello up to my hub, up to my SignalR hub. And then basically at that point, here, oops, in my chat hub, sorry. In my chat hub, I'm saying I want to broadcast the same message to all my clients, and I'm going to broadcast the same message back. So I have two clients. I have a IE window and I have a Chrome window. So if the IE window then says, how do you do? Dave on the IE window has sent the message, how do you do, back up to the chat hub, and then the chat hub has then broadcast that out to all of its clients. So that makes it very easy just to start kind of communicating and creating sort of this real simple chat application. And so that's great, and you can have a lot of fun with that. But something else I think is kind of interesting too is maybe I don't want to just have a plain old chat application. Maybe I want to be able to take data that's coming in from some stream, and I want to be able to sort of broadcast that out to different clients. Maybe I don't want to have an I don't want somebody to have to type this in. Maybe it's coming in from some other source. And so that's what I'm trying to do here sort of with this broadcast approach. So another hub that I've created, I'm going to close chat here, is a little bit more complicated. But essentially what I'm doing is I have a game hub that I've defined. And so what game hub does is it's doing a couple of different things. So game hub, obviously you can see, derives from SignalR's hub class. So I'm defining that this is a hub that clients can communicate to. I'm actually giving it a different name than the class itself. So I'm specifying exactly what the hub name happens to be. And what I'm doing is I have two different methods available on this hub. So I want to get all games. So basically I'm going to return back all the different games that I know about, and then also update game. And so the get all games, as you probably get, returns back these 3 different baseball games that are about to start. Update game is what's going to be called when a hit occurs, a run is scored, or an out is made. So what we're going to do is we're going to call this update game method on our hub, and what we're going to do is we're going to pass in the ID of the game and then an updated game instance, and then that essentially is going to be broadcast back out to everybody. So the game itself, we take a real quick look at what this looks like. Essentially, this has all the information about what a game happens to be. How many home runs or how many runs the home team has, how many runs the away team has, and so on and so forth. The box score itself. So notice that we're sort of holding on to this little box score thing. What box score is going to do is it's going to kind of be this inner controller of the hub. So the hub is going to receive all these different requests, but I want to be able to process them sort of at just one at a time because I don't want to overwrite anything. I want to ensure that these messages get delivered the right way and get updated the right way. So what I'm doing is within my hub itself, I have this box score, and really it ends up has a reference to all the different clients that happen to be connected to the hub itself. So I've passed this in sort of in a DI dependency injection type of approach. And then in here is really where I am querying maybe my internal data store. So I sort of have this internal list of games. This very well could be a database or some other repository, but I'm basically shielding that essentially from my hub. I'm letting the hub kind of talk to something else in order to get to my repository, so I sort of have another layer there that I can work with. And then I provide basically 2 ways to get data. Again, I have sort of just a wrapper call to get all games. That's going to return back all the games that are in my list. And then actually update game, which will go through and update a specific game that happens to be in my list. So imagine this being sort of like a store procedure that updates a particular game based on the ID. So it's pretty simple in terms of what's happening. But what the nice thing is that Game Hub here is still the hub that this communication goes through. I don't really want my client application to go ahead and update games, or I should say my browser application update games. I want the browser application just to get that data in. So if I'm looking at ESPN or some other application, I want to see all the different box scores sort of update whenever things tend to happen. And then I have this game controller here. And so the game controller, again, just has a reference to the hub. This hub here essentially is just a singleton based on how we've defined it. And I've just exposed a single web API method called put. This guy's not really going to do anything. The get won't do anything. But all the put's going to do is allow me to communicate to this web API method to say, I want to be able to update this game and then update, pass the update in. So how I'm doing this is I want to communicate to my web API via a console application. So I have another little program running here, so a little exe. And all this exe is going to do is basically read in a JSON file. So let's assume that there's some stats server out there that's just pumping me events constantly. Like, the Pirates have 1 out, the Pirates have another hit, they have another run, and they're basically just pumping me these stats nonstop. That's kind of what this JSON file is simulating. So basically, I read the information from this JSON file in. I establish an HTTP client connection to my web API. So notice that all I'm basically saying is I want to connect to my web API. This is the URL for it. It happens to be running under a private port. And I just want to add a header. So the HTTP client class for web API communication is really straightforward to use. I can add new headers however I want. I want to send a JSON value up to my web API. So basically, all I'm going to do is I'm going to loop through every single game that came out of that JSON file. I'm going to just loop through it, and I'm basically going to say, well, if it's the top of the inning, do something with the away team. If it's the bottom of the inning, do something with the home team. Update just the stuff that doesn't care if it's the top or bottom of the inning, and then send this game over to my web API so they can update SignalR, and then SignalR can just let everybody know what's happening. So how this all runs is I have this awesome little console app. Let me bring him over. So I guess the big finale, right? So you notice here I have 3 games playing. I have 2 different browsers opened up. They're both connected to the same hub. So if I hit enter to begin, what's going to happen is it's going to read that JSON file in and start processing these events. And so what's happening here is that I kind of do a little bit of shading as each team here gets updated. But what's happening is that, okay, the Pirates St. Louis game is happening right now. It's in the top of the 2nd inning. There's 1 out. Okay, now it's switched over to Washington. There was an update over there. And then as it kind of just rallies through, handles the different updates that are sort of streaming in from this event source, it will just update whatever game happens to be updating. And so what's happening is that, as you saw, that console application is getting those events in. It's calling a web API. That web API is talking to the SignalR hub. These 2 browsers are connected to that same SignalR hub, and the hub is broadcasting out to all the different clients saying, hey, this game has been updated. You need to update your box score. And so just with a little bit of jQuery, I'm able to find the particular games that are being updated, and I can go ahead and update their box scores. I'll put all this code up on GitHub, and I'll tweet out when it's out there. My GitHub account is just David Herster, so you can follow it there if you want. But it should have it out there in the next day or 2. But other than that, we're basically hit the time limit here. And one last thing I did want to mention, if you just want to stay on for like another minute, is the thing around scaling out. So the thing with SignalR is that it's really tied to sort of the server that you're on. So a client happens to be connected to that server, and so there's this WebSocket between the server and the client. And in terms of scaling out, that doesn't work really well, because if I happen to be, actually I like this image because it's off of the Microsoft site. If I happen to be connected to this client, but this server here, or I'm connected to this server here is doing some update with SignalR, really only this client's going to find out about it. These guys aren't. So what's really nice is that SignalR also comes with this concept of a backplane. And you can set a backplane up to either go against SQL Server, Redis, or an Azure server bus, or service bus. It's very simple to set that up. It's essentially 1 line of code, and then as soon as I show this line of code, I'll turn things back over. But essentially, all you need to do is just set up a dependency resolver. You add in another NuGet package that's specific for Redis. And if I stop this, the NuGet package is right here for SignalR. I think it's with Redis. Yeah. So basically, just do a search for SignalR Redis on NuGet, bring that in, and then essentially just this 1 line of code enables your SignalR application to use Redis in the background as that backplane. I had an example with that, but we'll save it for another day. So with that, I'm out of time, and I'll turn it back to Pat and see if we have any other questions or all that.
Thanks, David. Appreciate it. That's awesome information. I didn't see any other questions come in. We have a final slide I'll put up for about a minute or so, and then if a question comes in, we can answer at that point. Otherwise, I just put on here our next Oxygen Blast, June 24th on SSIS, and then some upcoming ASP.NET trainings. And there are some new case studies on our website around ASP.NET consulting as well. So feel free to check those out. As I mentioned when we kicked this off, we did record this, and I will be getting that soon, putting it up on YouTube, and I'll be sending out an email to the group so that everyone can see that. So with that, I think, David, I don't see anything else coming in right now. Oh, I just see something from Tani here. Where can you download the PowerPoint and sample? David, I'll let you answer that one.
I will put the PowerPoint up on SlideShare. I will put the code up on my GitHub account. My GitHub account is David Herster. I forget what my SlideShare account is. But I'll tweet that out, and I'll also blog it in the next day or 2. So.
And if you provide me those links, David, I'll put it in the email that I send out with the recording, since we have everyone's email here that registered for the event. So
okay.
You provide me those, and then we'll get those in the email, and then everyone else will see it.
Okay, sounds good.
Awesome. Thank you. Thank you, everyone, for attending. Have a great day.
Thank you.